On day two, we want to talk about uh, a different concept or kind of extending on the concept of vectors with something called the unit vector. So if you kind of recall, the meaning of unit, like a unit circle, is that you have a base, I guess, unit of 1. So basically, this is your basic thing. Uh, this is the basic vector. So this is the vector that has a magnitude of 1, or you can say the length is 1. There are two standard unit vectors. One is called the I vector, or just I. It is the vector is 1, 0, and then that marks the x direction. And then there is a j vector that marks the 0, 1, that is 0, 1, which marks the y direction. So I'll show you what that means. So let's look at one question. Let's say that vector v is 2, 5. So let's draw 2, 5. Okay, now it says, please express this vector as a linear combination of I, j. What does that even mean? Well, let's look at your ij vectors first. So the I vector is the 1, 0 vector. So let's draw out the 1, 0 vector. 1, 0 is this one. And then the j vector is 0, 1. So 0, 1 is this way. So let me just label, whoops, and then j. So when it says express 2, 5 as a linear combination of I and j, what it's saying is if we have to kind of write 2, 5 as a combination of the I vectors plus the j vectors, then what would you have to do? Well, this is actually pretty simple. So if you look at it, 2, 5 is this vector that's pointing towards 2, 5. Now, I vector is the standard unit vector, so pointing towards the x direction with a unit with a magnitude of 1. So then if you kind of ask yourself, if I have this I vector like so, how many I vectors do I need to go to where this vector is? Well, if this vector only moves in the x direction, then I need to move it 2 vector long, I guess, like so. And then if you ask the question, how many j vectors do I need to go to the end of this vector? Then you would say, okay, that is 1 vector here, 2 vector, 3, 4, 5. So then this takes 5 j vectors. Therefore, if you write this vector 2, 5 as a linear combination of I and j, you would say this is really just the I vector twice plus the j vector 5 times. So basically 2 times I vector plus 5 times j vector is going to be the v vector. Okay, let's show that algebraically this is correct. V vector is 2, 5. And then 2 times the I vector plus 5 times the j vector. Oops. Okay, so let's solve this. So scalar times a vector, you just multiply each component with the scalar. And then adding the two vectors together, just add the similar components together, 2, 5. So this is actually really easy. So in order to break this apart into linear combination, you take the x component and then you multiply it by the I vector, and then take the y component and multiply by the j vector. All right. Now, we're not limited to using the standard I and J's unit vectors to describe vectors. So I and J are standard unit vectors, meaning, first of all, unit vector means a vector that is 1 unit long, and standard means it points in the standard direction, as in just x and y. We can also create a unit vector in whatever direction we prefer. So for example, if we have this same vector again, 2, 5, we can actually shorten this 2, 5 vector so that it is only 1 unit long. So for example, if I were to figure out a way to say, you know what, I really don't want to point towards the I direction or the J direction. I want to point in this 2, 5 direction, but I don't want it this long. I just want it one unit long. Then if somehow I can create a vector that is going in that direction, but just 1 unit long, then I can use it as a unit vector. Well, how would I actually do that? Well, it's actually pretty easy. What you would do is you would take the vector and divide by its magnitude. That will shorten it down to just 1 unit long. So let's look at an example. Find a unit vector in the direction of -3, 2. So -3, 2, -3, 2 is here. So this is not asking for the linear combination of I and j. If it says linear combination of I and j, you would do what we were doing before. You would say, oh, okay, so you would say -3 going in -3 times, -3 times in the I direction plus 2 in the j direction. But this is not what the question is asking for. This is asking for creating a unit vector. So what we do is if we want a unit vector going in the v direction, we take the vector v, we divide by the magnitude of v. All right, so the vector v is -3, 2 divided by the magnitude. This is -3, 2 divided by 9 plus 4 is 13. All right, dividing by a scalar, so -3 over square root 13, comma 2 over root 13. Okay, so this is the standard unit vector. If let's just, for verifying, let's actually put those numbers in a calculator to figure out where that vector is. So -3 divided by root 13, -0.832, and then 2 divided by square root 13, 0.555. So then if we were to graph that vector, it's this is all approximate. So -0.8 and then 0.5. So about here. So then you can see that this vector and the original vectors are pointing in the same direction, except this has a magnitude of just 1. All right, let's have you try it. Find a vector in the direction of the given vector. First, write the answer in component form, and second, write the answer in linear combination of I and j. Okay, I think I'll just show you how to do one, and then you can do the other one. So find a unit vector in the direction given by the vector. So the direction given by the vector is in the -3 direction. Now they want a unit vector, the unit vector going in this direction. That means take this vector and divide by its magnitude. Okay. And then I'm going to simplify this just a little bit. And then divide. All right, so this is the vector. Now they say they want you to first write this in component form. The component form is this form. The second one is linear combination. Linear combination means take the x component and then make it go in the I direction, and then plus, or in this case would be minus, 1 over root 2 in the j direction. All right, let's have you try one. All right, go ahead and check your answers. Okay, so we said that vectors are defined by two things, magnitude and direction. So we already talked about how to find magnitude or the length of the vector. Now we're going to talk about how to find the direction of the vector, or what direction means. When we talk about direction, we're saying which where is it pointing? Now, when we're talking about, how to describe direction, we're actually going to describe it with an angle. And therefore, we call this the direction angle. So for example, let's say this vector points this way, and let's call this vector v. It's going to have some direction or some angle that you make this angle with the x-axis. So in order to figure out this angle, what we are going to do is draw a straight line down from the tip of the vector, which creates a 90 degrees with the x-axis. And so what we can do to find the angle is, first you can see that this creates a right triangle, right? So in order to find the angle, we can utilize this side and this side, or even this side, to find the angle. So what we're going to do is first figure out the lengths. So since it's a vector, it's going to have some kind of length. So that length is the magnitude. So then we're going to talk about how long is this part, which I'm going to call x, and then how long is this part, which I'm going to call y. If we know that this hypotenuse is length magnitude v, then how long is x? Well, since this is the right triangle, we can use SOHCAHTOA. In order to find x, we would say, okay, this is the angle, this is the side we know, this is the side we don't know. So then what trig ratio would this make relative to this angle? Well, if it's this angle, then this side is adjacent, this side is hypotenuse. Therefore, we're using cosine. So cosine of the angle is equal to adjacent over hypotenuse. Solving for x, x is equal to magnitude of v times cosine theta. All right. Similarly, if we're trying to find y here, we would also take the same idea and say, okay, this is an angle I know. I want to find y. I only know hypotenuse. So what trig ratio would make up these two sides? Well, this is the opposite side. This is the hypotenuse. So this is going to be sine. So sine of that angle is equal to opposite side over the hypotenuse. So y is equal to magnitude of v sine theta. Okay, so let's go ahead and write that down. Okay, now that you know this definition, what you want to do is just memorize it. So if you're given a vector with this kind of length, if you want to figure out the two sides that make up this vector or so, you would just use, for the x direction, magnitude cosine theta. Okay, so kind of easy because we already kind of talked about how x direction is cosine. And then the y direction is magnitude sine theta. So this is what we call resolving the vector. Resolving means break it down. Take this vector and break it down into its x and y component. So then what it's saying is if you go in x direction this much and then go in y direction this much, you're going to get this vector. So let's go ahead and solve one problem together. Oops, sorry. Find the components of vector v with direction angle 115 and magnitude 6. So the components means find the x and y. So you know this vector is going to have this angle and this magnitude. So you can just use the formula. So the formula says magnitude cosine theta gives me the x direction, and then magnitude sine theta gives me the y direction. Therefore, 6 cosine 115 and 6 sine 115 is the answer. And then what you want to do is just use the calculator and figure out the actual numbers. So it's about negative 2.54 and 5.44. Okay, let's have you try this really quickly. Find a vector v with direction angle 120 and magnitude 2. All right, since angle 120 is actually a value in the unit circle, you can just use the unit circle to help you. So the vector is negative 1 square root 3. All right, now opposite, in the opposite direction. So given a vector, now find the magnitude and direction angle of the vector. So instead of going from magnitude and direction angle to the vector, we're going backwards, vector back into magnitude and direction angle. All right, so this is also not that hard, but you just kind of need to see it once. So first, you have this vector. So what you want to do is draw out where the vector is. So this is a u vector. To find the magnitude, that's pretty easy. We've already found the magnitude a few times with other problems. So it's the square root of a squared plus b squared. All right, next, direction angle. That's this angle here. So the question is how much is that angle? Well, we know that again, we can draw the right a straight line down, and that creates a 90 degrees angle, and then this basically creates a right triangle. So what we can do is kind of talk about the lengths of this triangle. So we can see that here, this is the horizontal length of the triangle is 3, and here is 2. So then the question is, what is theta? Well, you can see that if we just use these two side lengths, we can find this theta. We just have to figure out which trig ratio does these two sides make. Well, this is the opposite side. This is the adjacent side. Therefore, we use tangent. So tangent theta is opposite over adjacent. And now we just have to find theta. So what you're going to do is to get rid of tangent, you always use the opposite function, which is inverse tangent. So theta is inverse tangent 2/3. And then what we're going to do is use the calculator, but make sure your calculator is in degrees. So inverse tangent 2/3, 33.69 degrees. Okay, so this question just says find the magnitude and direction. So this, and we're good. If they say to resolve the vector, then you probably will have to write something like this. Square root 13 cosine 33.69 degrees and square root 13 sine 33.69 degrees, meaning please write out the x component and the y component. All right, let's look at another one. So this one is a little bit trickier, so let me do this for you. So -2, -5. All right, so let's find the magnitude and direction. So magnitude is pretty easy. Again, you just do a Pythagorean theorem. -2 squared plus -5 squared. So this is square root 29. To find the angle, it's a little bit trickier. The angle is actually like so, but that's hard to find. So here's my trick on finding it. What I do is I create a right triangle again, and by drawing a straight line to the x-axis. And then what I'm going to do is I'm going to focus just on this triangle, and I'm going to ignore the other parts. So if I just have that triangle, the question is, how long is this side? Well, this side is 2. Because we're talking about just a triangle, I'm not going to put -2. And then same thing here, the vertical length, that is 5, not -5, because I'm just talking about this triangle. What I'm trying to do is I'm trying to find this angle, and I'm going to put theta prime to say that it's not the actual angle. The actual angle theta is from the 0 degree. Now what I'm going to do is find the angle just like how I did it with the previous one. So tangent of the angle is equal to opposite over adjacent. So opposite over adjacent, and then find the angle. $68.199. All right, so 68.199 is, I'm sorry, that should be prime. So that is angle prime, so 68.199. But that's not the direction angle, right? The direction angle is all the way from 0 degrees. So what do we have to do in order to find this angle from 0 degrees? Well, we'll have to add up this much, right? 68.199 is just this part. If I want it from 0 degrees, I need to add this much. The question is, how much is that? Well, that is 180 degrees, right? So then the actual angle in this case is 180 plus 68.199. So that is 248.199. Now let's start on section 6.2. There is this idea of dot product. So what dot product is taking the two vectors and then in a way multiplying them together to get this value. So dot product, or sometimes we call that an inner product, the result is a scalar. So if you recall, scalar means a number. So that means you should get a number as your answer. All right, dot product is pretty easy. So u dot v, we say the answer is, or to find u dot v, there are a few ways you can do this. The first way is you just take the exponent component times the x component of the second vector plus the y component of the first vector times the y component of the second vector. So that's going to give you a number. The second method is magnitude of u times magnitude of v cosine theta. All right, so let's really quickly find the dot product by each method. So the dot product is taking, so let's say 3, 4 is dotting, 5, 2. So this is not quite multiplying, but it's dotting. So what you're going to do is take the x component of the first one times the x component of the second one plus y component of the first one times y component of the second one. Okay, 15 plus 8, which is 23. All right, let's look at the next one. 2i minus j times, or dot, 3i minus 5j. So this is kind of, tricky because it's not in the vector component form, but we can always change it to component form. 2i minus j just means 2, negative 1. Dot 3i minus j, 5j equals 5, negative 5, 3, negative 5. So then if you dot the two vectors together, that is 2 times 3 plus negative 1 times negative 5. So this is 6 plus 5, which is 11. Okay, so now let's look at a different question. If you have two vectors, can you find the angle in between? So if you have these two vectors, 2, 3, and negative 2, 5, can you figure out what this angle is? Well, of course you can, but it's gonna, if you kind of take the approach of finding this angle, and subtract everything from 180, it's a little tedious. So what we can do is use dot product to help us. All right, so here's how dot product is going to help us. So if we say u dot v, remember u dot v has a different definition. That is the magnitude of u times the magnitude of v, and then cosine of the angle in between them. So let's use that method to help us. So in this first u dot v, what I'm going to do is just do the x times x plus y times y method. So 2 times -2 plus 3 times 5. In the second one, I'm going to find the magnitude of u times the magnitude of v and then cosine theta. All right. What I'm going to do is solve for theta. So, the math is a little bit long, but it's simple math. Okay, so 2 times -2 is -4 plus 3 times 5, that's 15. So -4 plus 15 is 11 equals square root of, that is 4 plus 9, 13 times, this is 4 plus 25, so that is 29 cosine theta. I'm going to divide by both of the square roots. All right, and then use the calculator to figure out what that is. Make sure you put this in parentheses if you're going to divide everything at the same time. Okay, 0.5665 equals cosine theta. All right, so finding theta, do inverse cosine on both sides. 55.491 degrees. So the angle in between these two vectors is 55.491 degrees. Okay, let's have you try B. All right, for B, the angle is 135 degrees. All right, last thing we're going to do is just very quick properties. All right, u dot v is the same as v dot u, so the order doesn't matter. U dot u is actually going to be the magnitude of u squared. The zero vector times any vector is the zero vector. And then if you kind of think of it as you're distributing a vector, so u times or dot v plus w is u dot v plus u dot w. And then same thing, if you take u plus v first and then dot w is the same, u dot w plus v dot w. And the last part is if you take a scalar c times vector v and then dot times vector u and then dot v, then you can actually change the direction or change the order you do this. It doesn't matter. Now, what does it mean when the dot product between the two vectors is 0? So if you get 0 and then you say, okay, well, that's equal to this formula, so then what does that mean? Well, the only way you're going to get 0 is, you can't have u and v be 0. So then that means cosine of something is equal to 0. So then the question is cosine of what angle is equal to 0? Well, that angle has to be pi over 2 or 90 degrees. Therefore, if the two, so if you take the dot product and then you get a 0, that means the two vectors are perpendicular to each other. Now, when we say perpendicular in the vector world, we call them orthogonal. So orthogonal means perpendicular. And then the dot product would be 0. So if the question says, figure out if u and v are orthogonal, all you have to do is take the dot product. So this is 3 minus 3, which is 0. So that means, yes, they are orthogonal.